Did you know that a quantum computer, operating at full capacity, can process data at a rate nearly 100 million times faster than your everyday laptop? Mind-boggling, isn't it? But how does this happen? To understand this, let's delve into the fascinating world of quantum computing. Quantum computing, in its essence, is a type of computing technology that takes advantage of the quantum phenomena such as superposition and entanglement to process information. It's a radical departure from classical computing, which relies on bits, the fundamental units of information that exist in one of two states, 0 or 1. Imagine walking into a library filled from floor to ceiling with books. If you're looking for a specific piece of information, a classical computer would start at one end of the library and read through every page of every book, one by one, until it finds what you're looking for. It's a linear process that, while reliable, can be time-consuming. Now imagine if you had the ability to read all the books in that library, at the exact same time. That's what a quantum computer does. It doesn't see information as a series of zeros and ones, but rather, it sees all possible combinations at once. This ability to process multiple outcomes simultaneously gives quantum computers their incredible speed and power. But it's not just about speed. Quantum computing represents a shift in how we approach problem solving. It opens up new possibilities in areas like cryptography, material science, and artificial intelligence, where classical computers are starting to hit their limits. So, how much more powerful is a quantum computer? While it's hard to quantify exactly, the potential is staggering. Consider this. If a problem would take a classical computer several thousand years to solve, a quantum computer could potentially solve it in just a few seconds. So, if we think of classical computing as a horse-drawn carriage, quantum computing is the rocket ship. It's a whole new frontier, a new era in the realm of computing, and we're just at the dawn of its exploration. In the heart of every quantum computer lies the qubit, a strange and fascinating creature that defies the laws of classical physics. To understand a qubit, let's start with the basics. In classical computing we have bits, the smallest unit of data. A bit is like a coin that can either be heads or tails. It's either a 1 or a 0, on or off. Simple, isn't it? But here's where quantum computing shakes things up. Instead of being limited to two states like a classical bit, a qubit can exist in multiple states at once thanks to a property known as superposition. Now imagine our coin again. In the quantum world, this coin isn't just heads or tails. It can also be spinning in the air, representing a state that's both heads and tails at the same time. This ability to exist in multiple states simultaneously allows a qubit to hold more information than a classical bit. But that's not all. Qubits can also interact with each other in a way that classical bits can't, through a phenomenon known as entanglement. When qubits become entangled, the state of one qubit becomes linked to the state of another, no matter how far apart they are. This means that a change to one qubit will instantaneously affect the other, creating a sort of quantum domino effect. This interconnectedness allows quantum computers to process complex computations at an astonishingly fast pace. So, you see, qubits are not just a fancier version of classical bits. They represent a fundamental shift in how we process information. They're not just about doing things faster, they're about doing things differently. They're about exploring new landscapes of computational possibilities, about venturing into territories that classical computers can't reach. In the end, it's like comparing a horse-drawn carriage to a spaceship. Both can get you from point A to point B, but the spaceship can also take you to other galaxies. So, a quantum computer doesn't just think faster. It thinks in a fundamentally different way. Imagine a world where new drugs are designed in days, not years, or where climate change models are so accurate they can predict the weather years in advance. This isn't a science fiction dream, but a potential reality with quantum computing. Let's explore this fascinating future, starting with medicine. Quantum computers could revolutionize drug discovery, a process that currently takes years and costs billions. Quantum algorithms can analyze and simulate molecular structures in a way traditional computers can't. They could enable us to design new drugs faster and more efficiently. Imagine solving complex health crises like cancer or Alzheimer's with this quantum-powered speed. It's a future where medical breakthroughs are not just possible, but probable. Next, let's consider climate modeling. Current models are good, but they have limitations. Quantum computers could offer a level of precision we've never seen before. They could simulate complex climate systems, predicting weather patterns and natural disasters years in advance. This could lead to more effective disaster prevention and response strategies, potentially saving countless lives. Now, On to cryptography. Today's encryption methods might become obsolete in the face of quantum computing power. Quantum computers could crack codes and passwords in seconds that would take current computers millennia to solve. But it's not all doom and gloom. Quantum cryptography could offer a new level of security, creating codes that are virtually impossible to break. While this has some scary implications like the potential for unbreakable malicious codes, it also opens the door to a future with unprecedented cybersecurity. Finally, let's talk about artificial intelligence. Quantum computing could supercharge AI research. AI algorithms thrive on data, and quantum computers can process massive amounts of it in record time. This could lead to AI systems that are more intelligent and capable than anything we've seen before. The implications are vast, from smarter virtual assistants to more precise medical diagnostics. Of course, this also raises ethical questions about AI control and job displacement. In every field we've discussed, quantum computing holds incredible promise. But it's important to remember that with great power comes great responsibility. We'll need to navigate the ethical and societal implications carefully. It's not just about what we can do with quantum computing, but what we should do. The future of quantum computing is not just exciting, it could reshape our world. As we stand on the cusp of this new era, we must approach it with both anticipation and caution. Our decisions today will shape the quantum future, and it's up to us to ensure it's a future we want to live in. But before we get too excited, it's worth noting that quantum computing still faces significant challenges. As quantum computing strides into the future, it's not without its share of hurdles. One of the most significant technical challenges is error correction. In classical computers, information is either a 0 or a 1, but in quantum computers, qubits can be both at the same time. Sounds impressive, right? However, this also means that quantum computers are much more sensitive to errors. Think of it as walking a tightrope while juggling. The room for error is extremely narrow. Moreover, maintaining quantum coherence presents another challenge. Quantum coherence is the delicate state where qubits exist in multiple states at once, allowing quantum computers to perform complex calculations at a speed unattainable by classical computers. However, this state is incredibly fragile. Any form of interference, be it temperature fluctuations or electromagnetic waves, can disrupt this state, causing the qubits to lose their quantum properties. This is known as decoherence, and it's a major roadblock in the path of quantum computing. Despite these challenges, let's not forget the immense potential of quantum computing. It's like harnessing the power of a star. Yes, it's challenging and fraught with difficulties, but the potential benefits are astronomical. Quantum computers could revolutionize everything from drug discovery to climate modeling, propelling us into a new era of scientific discovery. However, it's important to remember that quantum computing isn't going to replace classical computing, at least not yet. Think of it like this: you don't use a rocket to go grocery shopping. Similarly, quantum computers with their immense processing power are overkill for everyday tasks. For now, classical computers are still the most effective tool for most computing tasks. So where does this leave us? Well, quantum computing is still in its infancy. It's a field filled with immense promise, but also significant challenges. It's like standing on the cusp of a new frontier, peering into the unknown. It's thrilling, terrifying, and filled with possibilities. The world of quantum computing is like a complex, intricate puzzle. Each discovery is a piece that brings us one step closer to the complete picture. It's a journey of exploration, of pushing the boundaries of what we know and venturing into uncharted territory. So, the next time you're frustrated with your laptop's speed, just remember, the quantum future is on the horizon, and it's moving at the speed of light. Yes, we may not be there yet, but every day we're getting a little bit closer. And who knows, maybe one day we'll look back and marvel at how far we've come. Until then, let's keep exploring, keep innovating, and keep reaching for the stars.